Hi folks, this is Calc 2, Checkpoint Quiz 4. In number 1, we're asked to find the derivative of some functions. So we'll start with part A. We're given f of x equals the square root of 1 plus e to the 3x. So, like oftentimes in calculus, we're going to rewrite this as 1 plus e to the 3x to the 1/2 power. And now we're going to do the chain rule. So f prime of x is the derivative of something to the 1/2 power is 1/2 times that something to the minus 1/2 power times the derivative of what's inside. Now to take the derivative of what's inside, we're going to use the rule. The derivative of e to something is e to that thing times its derivative. And the special case we talked about in class, which happens more often than not, if we take the derivative of e to the kx power, that's just k e to the kx power. So we get 1/2 the quantity, 1 plus e to the 3x to the minus 1/2 power times the derivative of 1 is 0 plus the derivative of e to the 3x with k equal 3. Here we get the formula 3e to the 3x. Alright, and so simplifying in the numerator, I'm going to have a 3e to the 3x divided by 2 times the quantity 1 plus e to the 3x to the 1/2 power. So that'll do it for part A. Okay, in part B, we're given y equals e to the x plus e to the negative x all over 2, and we're asked to find the second derivative of that. So once again, I'm going to slightly rewrite this. I don't want to use the quotient rule on this because what's in the denominator is a constant. So I'm just going to rewrite this as 1/2 times the quantity e to the x plus e to the minus x. So when I take the derivative of that, the 1/2 just goes along for the ride, and I take the derivative of what's inside. Well, the derivative of e to the x is e to the x. The derivative of e to the negative x is going to be negative 1 e to the negative x. So I get minus e to the negative x. So that's the first derivative. Now for the second derivative, once again, the 1/2 goes along for the ride. The derivative of e to the x, once again, is e to the x. The derivative to e to the negative x, once again, is going to be negative 1 times e to the negative x. But since I have that subtraction out front, the two negatives are going to cancel, and I get this. And the observant reader or watcher or viewer will notice that this is exactly the same formula I had for y. So here's an example of a non-trivial function who, after two derivatives, comes back to himself. That'll do it for part B. Okay, in part C, we're asked to take the derivative with respect to t of t squared 2 to the t. So this showcases the difference between these two constructions. Here, the variable is in the base and we have a constant in the exponent. Here we have a constant in the base and a variable in the exponent. But no matter how you slice it, we've got the product of two functions of t here, so we have to use the product rule. So I take the derivative of the first factor times the second plus the first factor times the derivative of the second. The derivative of the first factor, t squared, that just follows the usual product rule, or power rule rather, so I get 2t times 2 to the t plus t squared times, and now I need to take the derivative of 2 to the t. So as we showed in class, we can actually convert this back to an exponential that looks like this, and doing that, we get the formula. The derivative of a to the x is a to the x natural log a. So it's roughly the same exponential we started with, we just need to multiply by the natural log of the base. So in this case, I'm going to have 2 to the t times the natural log of 2. All right, how can we simplify this? I'm taking 2 times t times 2 to the t. I can group the 2's together and think of this as 2 to the first power. So I've got t times 2 to the t plus 1 power plus, and then here there's really nothing I can combine. I'm just going to leave it t squared times 2 to the t times the natural log of 2. So that'll do it for part C. Alright, now part D, we're given y equals x log base 2 of x minus x divided by the natural log of 2 plus 11d7. And we're asked to find y prime. So, how do we take the derivative of log base 2's? Well, by taking the derivative of log base a of x, it's pretty much the same as the derivative of natural log x, except I have the natural log of a hanging out in the denominator. So, since these functions are inverses of each other, this is completely believable. When I take the derivative of a to the x, I have to multiply by the natural log of a. When I take the derivative of its inverse, then I have to divide by the natural log of a. Okay, so let's go through. Take the derivative here, y prime equals. The first thing I encounter is a product of two functions of x and log base 2 of x. So I'm going to use the product rule. Take the derivative of the first factor times the second plus the first times the derivative of the second. So everything here, I'm just taking the derivative of that first term minus the derivative of this. Now, even though it looks a little frightening, the natural log of 2 is just a constant. So when we take the derivative of that, we'll just make a little note over here. X divided by the natural log of 2 is just 1 over natural log of 2 times x. So this is once again a constant times x. If I were taking the derivative of 3x, it's 3. If I take the derivative of 5x, it's 5. If I take the derivative of negative 3 halves x, it's negative 3 halves. So if I take the derivative of 1 over natural log 2 times x, the answer is 1 over natural log 2. Plus the derivative of 11d7, of course, is 0. Alright, so let's go in here. The derivative of x with respect to x is just 1. I have log base 2 of x plus x times, using this formula, the base here is 2. It's 1 over x natural log 2 minus 1 over natural log 2. And so we see what happens here. The x's cancel, and I'm left with a 1 over natural log 2 minus 1 over natural log 2. And so for my grand final answer, I get y prime equals log base 2 of x. So that'll do it for part D, and that'll do it for number 1.